In Denmark, a significant amount of heat and power is supplied from flexible CHP plants to the district heating network and power grid. CHP stands for Combined Heat and Power, two essential services. Cogeneration or combined heat and power production is a cost-effective way of reducing CO2 emissions. Whilst power is produced by generators, fueled by steam created from the boilers, excess heat from the production is distributed through the district heating system, which supplies more than 60% of all heat consumed by Danish households. The district heating system is an efficient way of using excess heat that would otherwise have been wasted. Moreover, it is a flexible solution for storing heat from electricity or industrial production. The widespread use of flexible CHPs is one of the most important reasons that Denmark has been able to reduce its carbon emissions and integrate wind power, while consumption has remained almost unchanged. In Denmark, district heating companies are run as non-profit, meaning they can't generate a financial surplus, but only covers the cost, making the prices lower for the consumers. Today, Denmark has around 670 centralized and decentralized CHP plants. The largest centralized plants are owned by one of the most sustainable companies, Ørsted, and the municipalities, while the smaller decentralized plants typically owned by industries, municipalities, or cooperative societies. The centralized plants initially produced electricity and were located in large Danish cities, whereas the decentralized plants originally were heat plants in medium-sized and smaller cities. One of the most important characteristics of CHP plants is their flexibility. This means that when the wind is blowing, the plants can ramp production down to allow the wind to meet the demand, keeping a balance in the system. Large CHP plants in Denmark typically have a minimum output of around 15%. On the other hand, when the wind is not blowing, there is a need to ramp up production in the plants to keep the lights on. CHP plants in Denmark can ramp up and down at a rate of 4% per minute, while reaching an overload of 115%. Heat storage tanks, storage pits, and electric boilers have made it possible for CHP plants to store energy and produce electricity or heat if and when the system requires. These technologies allow the plants to decouple heat and electricity production so the output is flexible, depending on the demand at any time. This is an important asset in the system since Denmark has so much wind energy which varies over time. The sector coupling between the power and heat sectors is a key reason for the success of integrating a high share of wind energy in Denmark. In the efforts of integrating the energy sectors with each other, the industry plays a vital role. Data centers, production sites, and power-to-X plants produce significant amounts of excess heat. In Europe, more heat is wasted in industrial processes than what it would require to heat the combined building mass. In Denmark, this excess heat is utilized by the district heating network and distributed to consumers as clean, renewable heat. Denmark's largest heat and power station, Avlværket, converted both of its two units from coal to biomass in 2014 and 2016. Both units of the plant can achieve fuel efficiencies over 90%. Other CHP plants generate heat and electricity from waste that is not recycled and that instead would have been put to landfill to decompose and thus produce emissions or even more immediate environmental problems. You are now inside one of the world's most advanced waste-to-energy plants, Amager Resource Center. Here we see the trucks unloading the collected waste from surrounding municipalities. ARC opened in 2017, less than 2 kilometers from the center of Copenhagen and the Royal Palace. It houses an artificial ski slope, a hiking route, and a climbing wall where the public can visit and enjoy the facilities, proving that waste-to-energy can coexist with a healthy environment and a livable city. All CHP plants in Denmark, regardless of size or fuel source, must abide by strict emission control requirements. Filtration and other technologies result in the majority of air pollutants being cleaned so they are not emitted to the air. While perhaps best known for the innovative use of its roof as a ski slope in central Copenhagen, ARC is one of the world's cleanest and most energy-efficient waste-to-energy plants. And they're aiming even higher, planning to capture 500,000 tons of CO2 annually by 2025. Just as the sky, the future looks bright ahead. I'll leave you here to enjoy the view. Thank you for watching.